Okay, guys, in this platform, we shall have a continuation of solving the equations that are under exponents. Remember, under our exponential equations, we had a consideration where we had to solve equations that are exponential equations. But in that case that we had, we're just having one solution. But in this case, if you are to check the typical questions, we shall be seeing that we shall be having more than one, meaning to say we are having two solutions. In most cases, we're just having two solutions. How is that possible? Having a question like what we're given in the first place, or number one, where we are given, in this case, that is x to the exponent of 1 over 2 minus 5x to the exponent of 1 over 4 plus a 6 like this. This is equal to 0. All right, so the question is, how do we solve such type of an equation? This is an exponential equation, we know. But how do we solve? All right, the first thing that we have to note that is different from our previous class is that the exponents here, they are different. So there is no way we can combine these two to be a single term. There is no way, because they are different exponents. If it was x to the exponent of a half minus 5x to the exponent of 1 over 2, we're going to combine because they are having the same exponents. They're like terms you can factor out there like what we did in the previous case. But it's different from that because the exponents this time, they are different. They are no longer the same like what we had previously. This is 1 over 2. This is 1 over 4. All right, so this is what you need. You compare the exponents that you're given. All right, there are two exponents here, the 1 over 2 and the 1 over 4. So you compare these exponents, which one is smaller? 1 over 2 as a decimal is 0.5. 1 over 4 from your calculator as a decimal is 0.25. So if we compare, we are going to see that 1 over 2, which is 0.5, is bigger than this 1 over 4. It is greater than 1 over 4, which is what? 0.25. Okay, so this is the idea here. We want to write, what you're going to do is write this one with a bigger number, with a bigger exponent, as or in terms of the smaller one, in terms of this, in terms of the smaller one. So we have to write the bigger one in terms of what? In terms of the smaller one. The smaller one that we are having is x to the exponent of 1 over 4 because we compared here. So that's, we want to write this as x to the exponent of 1 over 4 in terms of the smaller one. But what we need is that we are supposed to obtain the same exponent, the same, this one, x to the exponent of a half. So you have to ask yourself, which exponent are you going to use here? So that if you affect with the exponent, remember from our laws of exponents, a to the exponent of m when raised to the exponent of n is going to give us a to the exponent of mn. You multiply the exponent. So we need a number here that you're going to use to multiply, so that if you multiply these two numbers, you get the 1 over 4. We do not want to change the meaning of the question. The meaning is supposed to be the same. We are supposed to obtain the same x to the exponent of a half. All right, so which number are we going to use here? That will be a 2. So if you check here, if you multiply properly, 1 over 4 times a 2. All right, let us bring the calculator. I'm going to show you the way that you can have that number if you can't find them direct. All right, so this is 1 over 4. This number inside, remember, exponent multiplies. So it's 1 over 4 like this times a 2 like this. So you see that we haven't changed anything. This is going to give us a 1 over 2, which is this one, a 1 over 2. So we haven't changed anything, but what we just did is to write this in terms of what? In terms of the smaller exponent. It's always the smaller. You use the smaller one. That's why I said you have to compare these numbers. All right. In case that you do not know this, all right, like I said, you know that if I multiply this and this number here, I'm supposed to get a half. So this is what you simply ask yourself. I have got 1 over 4, this one. I'm supposed to multiply it to a certain number. I do not know that number. But after multiplying, I'm supposed to get what? I'm supposed to get a 1 over 2, which is the original question that I was given. So what is this number representing? What is this x representing? So you can just divide by 1 over 4 so that you know what this x represents, which is the number to be multiplied. So if you divide 1 over 2 divided by 1 over 4, you're going to get what? A 2. That is to show you that, that is that is for you to know the number here if you do not know the number that you're going to use. But these at the end, they formulate quadratic equations. So once you write in terms of the smaller one, you know that you're going to raise to the exponent of 2 to get this one. All right. The rest is going to remain as it is. Remember, we wanted to write this in write this one in terms of this. So meaning to say this one is going to remain as it is. The 5x to the exponent of 1/4 is going to remain as it is. But as we can see, we have formed another type of an equation, which is referred to as a quadratic equation, because now we have 2 as the highest exponent. Remember the format of the quadratic equation, okay? It is given in the form of ax squared plus bx plus c is equal to 0, where we have got a constant just like 6. So this one, if you check, the x is the same as this x, but being raised to the exponent of 2. This is what is representing our x. So it's a quadratic equation that we see. So we can either factorize this direct, as we can see from the format of a quadratic equation. Remember, I said if the coefficient of x squared, this one, is 1, like what we have, if the coefficient of this is a 1, we can simply have two brackets. Remember, here, this is x squared from x. So this is x to the exponent of 1/2 squared from the x to the exponent of 1/4 squared from the x to the exponent of 1/4 that we see here. So it means in our brackets, we are going to have x to the exponent of 1/4, x to the exponent of 1/4, which is this one that we are seeing, in order for us to have it as a squared. Remember from your factorization, guys, this is by factorization. Remember from your factorization. All right, by factorization. So like I said, from our factorization, what do you do after this? All right, this is a 1/4 here. Do not mistaken here. This is a 1/4. Remember from our factorization, if this is a 1, then you consider from the factors, the product of that. That's why, guys, I say you must also revise your basics from your grade 10. All right, this is now your grade 10. Remember from our factorization, we're saying we need the factors of the constant, which is the products, in this case, that are the factors of what? Of a positive 6. But these factors should give us a -5. So we need two numbers. You multiply these two numbers, you get a positive 6. You add the numbers, you get a -3. You get a -5, I mean. So you're going to see that we've got -3 and -2. If we multiply these numbers, -3 times -2, that's a positive 6. If we add these two numbers, -3 plus a -2 from your calculator, you're going to get a -5. So these are the numbers that we want. -3 and what? -5. That's a -3, sorry, and a -2. So from this, it's either one of these two brackets must be equal to 0. It's either x to the exponent of 1/4 -3 must be equal to 0, or the bracket of x to the exponent of 1/4 -2 must be equal to 0. So that's where now we see the two solutions. The two solutions now. From where? Remember from our basics. This is what we had from our basics. We said we can take this to the other hand of the equation so that it becomes a positive. X to the exponent of 1/4. The moment it jumps the equal sign, it becomes a positive. The 3, it becomes a positive. Or x to the exponent of 1/4 is equal to -2. Crosses the equal sign, it becomes a positive. How were we solving our equations before? Remember, we were looking for the reciprocal to remove the exponent, the 1/4, the reciprocal of 1/4, which is 4/1. Check the introduction. Make sure that you watch the introduction of this. We had the class on this one. So we have to find the reciprocal. So we raise this to the exponent of the reciprocal to the exponent of the reciprocal. The same thing here, the reciprocal, which is 4/1, which is same as 4. Remember, 4/1 is same as 4. So that if we multiply here 1/4 times a 4, we are going to remain with 1, x to the exponent of 1. And we understand that x to the exponent of 1 is same as what? Is same as x. So meaning to say here, we're going to have x. What about 3 to the exponent of 4? 4 times. This will give us 81. So from your calculator, you can also simplify this. 3 to the exponent of 4. For those numbers, you just raise to the exponent of what? Of a 4. That is 3 here. to the exponent of a 4 like this. So this is going to give us 81. On the other hand, you do the same, 2 to the exponent of a 4. So that's 2 to the exponent of a 4. And that is going to give us what? In that case, we are going to obtain, for this is the 16. So that's another solution, or x is going to be equivalent to what? To 16. So there are two solutions there. We are having two solutions. They are two solutions that we are going to obtain, either x being a 16 or x being 18. So that is what we are going to expect from these typical questions. Like I said, the first thing, you have to check for the one with the smaller exponent. Then you write the bigger one in terms of the smaller one. The one with the bigger exponent in terms of the one with the smaller exponent. So you're going to try that throughout. If you check, this is what is happening on question number 2. I'm not going to do all these questions, guys. I want you to try them. This is exactly what is happening on question number 3. Maybe you can try question 3. X to the exponent of 2 over 3 minus x to the exponent of 1 over 3 minus 2 is equal to 0. So you see that 2 over 3 is bigger than 1 over 3. 2 over 3 is same as 0.6666. 1 over 3 is same as 0.3333. So if you check, 0.6666 and so on is bigger than. So we said we write the bigger one in terms of the smaller, one, this one, the smaller one, x to the exponent of a third, this one. So it's going to be x to the exponent of a third like this, raised to the exponent of what? So that it gives us 2 over 3. So like I said, if you do not know, you divide, all right? 2 over 3 divided by 1 over 3, we're going to get what? We're going to get a 2. So if you multiply this, 1 over 3 like this times a 2, you're going to get a 2 over 3. We haven't changed anything, but what we just wrote is we are writing it as a quadratic equation raised to the exponent of 2. That's the idea there. Minus x to the exponent of a third minus 2 is equal to 0. So that is it. As we can see, this is a 1. Like I said, this and this are the same. So you can just factor out x to the exponent. All right. By the way, there's another way. Let me explain it. Okay. So this time, just like the previous case, we've got x to the exponent of a half, x to the exponent of a third, sorry. So you're going to have x to the exponent of a third here, x to the exponent of 1 over 3. So like I said, you have to focus on the constant. What are the factors of -2? But these factors should add up to -1. The products, two numbers that you multiply to get a -2. But these numbers, if you add them, they will give you a -1. There is -2 and a 1. There is 2 and a -1. If you multiply these two numbers, you get a -2. Very true. You get a -2. But when you add, which one? When you add like this, you get a -1. So that is the combination -2 and 1. If you add this, you get a -1. So that means we've got a -2 here and a +1 is equal to 0. One of these must be equal to 0. So x minus a third minus 2, x to the exponent of a third -2 must be equal to 0, or this bracket of x to the exponent of a third plus 1 must be equal to 0. So this gives us the x values by finding the reciprocal. But before that, transpose first your numbers to the other side of the equation. So x to the exponent of 1 over 3 will give you a +2 to the other side, or x to the exponent of 1 over 3. On the other side, 1 is going to be referred as a -1. What is the reciprocal of 1 over 3? We say the reciprocal of 1 over 3, which is the inverse. You just interchange. It will be 3 over 1. But 3 over 1, guys, is the same as what? It's same as 3. So we raise this to the exponent of 3. Also, this to the exponent of 3, the reciprocal, to the exponent of 3, to the exponent of 3, everything to the exponent of 3. So that's, if we multiply, we're going to have x to the exponent of 1, which is same as x. 2 to the exponent of 3 on your calculator, that is going to give you 8. All right, so this is going to give us an 8 in that case. Then to the exponent of 3 on that case, x is going to be a -1 to the exponent of what? To the exponent of 3. So these are the solutions that we were supposed to obtain. All right. Is this a -2? All right. So that's and -2. So meaning to say we're going to get 8 and what? 8 and -1. So these are the solutions that we're going to get from there. So guys, as we can see that all you just need is to know which one is the smaller exponent, which one is the bigger exponent. You write the bigger exponent in terms of the smaller exponent. So it can be confusing when you are given numbers such as number 5. If you check number 6, I mean, number 5 is direct there. You're going to use 1/4. All right, try. So I want you to try any questions. If you have a question that is challenging, let me know. But for now, let us try to have question number 6. On question number 6, we are given 5x plus 7, the square root of x minus 6 is equal to 0. The condition there is still the same. The idea there is still the same. All right, 5x, there's nothing that you're going to do. There's same as 5x. So this is same as 5x. All right, guys, I'm still forgetting to introduce another method here. All right, this is what you could have done before you solve that one. On this one, you could have introduced the k here. I wanted to talk about this before we solve that one, guys. Sorry for that. Here, we could have used a method where we are given x to the exponent on this part here. X to the exponent of a third like this, to the exponent of a half, minus x to the exponent of a third like this, minus 2 is equal to 0. You can also use the k method. All right, let in this k be equal to x to the exponent of a third. So that means in place of this, we're going to have a k, but being raised to the exponent of 2. So that's k squared minus here, we're going to introduce a k. So that is a k there, minus a 2 is equal to 0. So you factorize just like the previous case where there is a coefficient of k squared is 1. So you're going to have 2 brackets there, direct. So this will be k here. This will be k here. What are the factors of -2? But they must add up to -1. You see that we have got the same -2 and +1. These ones, -2 and +1. So you're going to have -2, +1. One of these must be equal to 0. So that means k is going to be equal to +2, or k is going to be transpose +1. That side, it becomes what? A -1. So remember, you introduced the k. You say let k be equal to, it was not part of our question. So we must answer the question now where we introduce the k, therefore we have it. So x to the exponent of a third, which is our k here, is equal to what? To 2. Or the same x to the exponent of a third, which represents k here, is equal to what? -1. So as you can see, we are back to these stages. You obtain 8 and what? -1, just like what we did by raising these to the exponent of the reciprocal of what you're given, the inverse of the exponent of what? A third, which is 3/1, which is 3. So they're going to have x being equal to 8, or our x being equal to -1. All right, so that is how you could have worked these ones. All right, so like I said, there are so many ways. So let's consider, or let's focus on our question, which is question 6 here. We said on this one, if we take a closer look, 7 square root of x, the square root of x is same as x to the exponent of a half, minus 6 is equal to 0, like that. So how do you solve this one? Still, you have to compare your exponents. There's an exponent here, x. There's an exponent. What is the exponent? It's 1. There is a 1 there. So you're comparing. Remember, I said you have to compare 1 and a half, the exponents. Which one is bigger, 1 or a half? A half, which is same as 0.5. 0.5, guys, is a decimal. So 1 is bigger than a half. So we are supposed to write this one here in terms of a half, like I said previously. So it's going to be 5x to the exponent of the smaller one, which is to the exponent of a half. But what are we going to use so that if we raise this to the exponent, it gives us a 1? Which exponent are we going to do? What are we going to use? That's a 2. Just like the previous case, x to the exponent of a half like this to the exponent of a 2. If you multiply a half and a 2, that is going to give you a 1. So meaning to say, we are obtaining the same one, that is one we are having here. All right, plus 7x to the exponent of a half, in this case, minus 5. This is minus 6, sorry. minus 6 is equal to 0. So this is what you're going to get. All right. So as you can see, we have formulated a quadratic equation. Most of us, we find it difficult to solve a quadratic equation of this nature when the number is no longer a 1, it's now a 5. All right. So we said we can introduce the K method. So let K be equal to what is common here, which is x to the exponent of what? X to the exponent of a half. So that's in place of x to the exponent of a half here. We're going to substitute this k. So that's 5k to the exponent of 2 plus 7k like this minus 6 is equal to 0. You solve for k. So it's either going to use the quadratic formula, factorization. I don't know what you're going to use. All right. So using the factorization method, remember we had a longer way of doing our factorization. In most cases of this nature, I prefer you doing that, because most of us, we have a confusion on solving this. I say this is what you do. You multiply the first term, since it's no longer a 1, there's a 5 there, it's no longer a 1. So you multiply the first term, this one, to the last term. All right? So you're going to multiply this to the last term. That is 5k squared times a negative 6. If you multiply this, you get negative 30k squared. So this is what you ask yourself. Do we have products, in this case, two terms, that we can multiply to get a negative 30? We get a negative 30 if we multiply, but if we add, we get a positive 7, which is a positive 7k as it is. But if you multiply, you get a negative 30. But if you add, you get a you get a positive 7. So there are so many numbers that gives us a negative 30. I want you to try as many numbers, but I want us to focus where we can get a 7. There's a 10 and a 3. So let us focus on 10 and 3. Let's say we've got 10k and 3k. The possibilities of getting a 30k squared are very, and they are there. But to get a negative, it means one of these must be a negative. So it can be a negative 10k and a 3k, or it can be a 10k and a minus 3k like this. If I multiply this, I get a negative 10. I get a negative 30. I get a negative 30 also. But which part now, if I add, that is the most important part. If I add them now, I must get a positive 7. If I add here, I get a negative 7k. But if I add here, I'm going to get a positive 7k. So these are the factors, 10k and what? Minus 3k. So please bear in mind, how do you factorize using this method? All right. So you take those terms. Take note, the two terms that you got, this one, minus 10k and 3k, you substitute them into this time, you put them here on the middle term. That is where you put them. So it is going to be 5k squared. You put them here. So it's going to be, we say these factors, remember, these are the ones that give us a positive. So it's plus 10k as it is, minus 3k as it is, minus 6 is equal to 0. So what have we done? We've got 4 factors. Remember, I said in your factorization from grade 10, if they are 4 terms like that, you factor this by grouping into 2. What is common between these 2 terms? 5k is the highest common factor. Please redo your factorization from grade 10. So if you divide this, that is going to give us a k plus 10k divided by 5. That is going to be a positive 2. The same thing, if you check, minus is common. So you're going to factor out minus 3. So that if we divide, this will be a positive k. Minus 6 divided to minus 3, that will be a positive 2. It is equal to 0. So as you can see, guys, the brackets are the same. So what do? We factor out the common bracket, k plus 2, into the bracket of what is remaining here. We remain with what? We remain with 5k. What about here? We remain with minus 3, must be equal to 0. So guys, like I said, these were our grade 10 equations. So please make sure that you go back and redo your questions. So from this, if you check properly, k is going to transpose 2 to the other side, is going to be a negative 2, or transpose minus 3 to the other side, it becomes a positive 3. Then we divide by this 5, which is in k. So it's going to be 5 over 3. So these are the values of k. So first you transpose this, then you divide by 5k. Remember the procedures, guys. So, but these are not our solutions. They are going to help us. These ones are going to help us to find the exact solution. What is the exact solution now? We go back to the introduction where we introduced our k. We said here, let k be equal to x to the exponent of what? Of a half. So if we introduced our k as x to the exponent of a half, what does it mean? It means we have to substitute back in place of this. Remember, we said k is x to the exponent of a half. So that means x to the exponent of a half must be equal to the first solution, minus 2, or x to the exponent of a half, the same k, must be equal to 3/5. So how do we find the value of k? I talked about the issue of the reciprocal of what you are given. What is the reciprocal of what you are given? The reciprocal of the exponent 2, in this case, from 1/2. 1/2. If you interchange, is 2/1. And 2/1 is same as 2. So you raise this to the exponent of the reciprocal, the inverse of this, also to the inverse, also to the inverse, each and everything. So the half and the 2 cancels, we get a 1. So that's x to the exponent of 1 is minus 2 squared. Minus 2 times minus 2 gives us a positive 4. Or x here again, half and a 2, that's a positive. This one, if you raise 3/2 to the exponent of 2, is going to be 9/25 on your calculator. 3 squared is 9, 5 squared is 25, or you can use your calculator direct. So these are the exact solutions for x. X can be 4, or x can be 9/5. These are the solutions that we are now obtaining from what? From the equations that we were given before. So you have to be very, very careful how your questions are given. Like I said, each and every part, you have to consider the type of question that you're given there and how do you answer that type of a question. So this is what you're supposed to do here. Whenever you see this x here, is just taken from the x to the exponent of a half. All right, x to the exponent of a half to the exponent of a 2, it gives us x. So this is where we have the x. All right, so this is the exactly one thing happening on question number 7. So we're not going to answer all of these questions, guys. Do as much questions. On question number 7 is the same approach again. X minus x to the exponent of a half. X minus x to the exponent of a half, in this case, minus 12 is equal to 0. This is what you're given. So if you check, I said this x is same as what? X to the exponent of a half to the exponent of a 2. If you combine this, that will be a 1. Minus x to the exponent of a half minus 12 is equal to 0. So this one, it's just a direct factorization. We can just do our direct factorization. The coefficient there is a 1. So you're just going to have 2 brackets. All right, x to the exponent of a half here, x to the exponent of a half here, this one. Then what are the factors of what? -6 from your factorization. And this is -1. Since we have what? A squared here. We are factorizing. So what are the factors of -12? That will give us a -1. There we've got -4 and a +3. If you multiply this, we get a -12. If we add, you get a -1. But there are so many factors. Try and see. You'll see that these are the only ones. There is -6 and 2. There is 6 and -2. But if you add, you won't get a -1. So all these, they'll be out because they do not give us what? A -1. So either one of these must be equal to 0. So that's x to the exponent of a half must be equal to what? Transpose -4 is going to be a +4, or x to the exponent of a half is equal to transpose -3, that, I mean +3 that side, it becomes a -3 on the other hand. All right, then the reciprocal of a 2, I talked about this guy, is 2/1. It's a 2. So that is to the exponent of 2 to the exponent of 2 to the exponent of 2 to the exponent of 2, everything. So x will be equal to 16. 4 times 4, that's a 16. Or x is equal to -3 squared, -3 times -3 is a +9. All right, so this is how you were supposed to attempt these typical questions. Do so on question number 8, question number 9, question number 10. Maybe you can just talk about question number 9. There's negative there. All right, so this one, let's see what are they trying to say here. All right, so on number 9, we are, on number 8, I mean, we are given x to the exponent of -1 minus x to the exponent of -half like this is equal to a 20. So like I said, guys, all you just need is, right, so you can avoid negative, which is fine. But you can still have the same thing with that negative, x to the exponent of -1 minus x to the exponent of -half, transpose this to the other side, it becomes a -20. So like I said, we talked about a 1. If you check here, there was a 1.5. There was x, and there was x to the exponent of half. Here it's now -half, -1. Here there was a 1. Now it's -half and -1. So what does it mean? We can write it as a -half. So we can write this x to the exponent of -1 as x to the exponent of -half as it is, but raised to the exponent of what? Of 2. -half times 2, guys, it gives us a -1. We still have a -1. All right? Minus x to the exponent of a -half is equal to, sorry, -20. There's an equal, so I forgot what I meant. Is equal to there. Is equal to 0. That's a quadratic equation. Why? The highest exponent that we are having is a 2. So from the factors here, from the concept that we've got 1, we're going to have 2 brackets. Factorize, we can use the K method, or just use the x to the exponent of -half as it is, x to the exponent of -half as it is, the one that is raised to the exponent of what? Of 2. Then consider the factors. What are the factors of -20? But these factors should give us a -1, the products of -20. So there is -5 and a 4. If you multiply this, you get a -20. If you add, you get a -1. There are so many factors: 5 and -4, 10 and -2, -10 and positive. All these ones, they are factors of -20, but you won't get a -1 if you add. It's only at -5 and at a +4. So that's it. One of these brackets must be equal to 0. So what does it mean? It means x to the exponent of -half must be equal to, transpose -5, it becomes what? A +5, or transpose this, x to the exponent of -half is equal, transpose +4, it becomes what? It becomes a -4. So what is the reciprocal, the inverse of -half? The inverse of -1/2 is 2 over -1. What does 2 over -1 mean, guys? 2 over minus, if you divide by 1, it's same as -2. So 2 to the power of, 2 over -1 is same as -2. So this here, the reciprocal is -2, the reciprocal -2, the reciprocal -2, the reciprocal that we use there, always -2. So remember, -half, -2 there, they cancel, we get a 1. So that's 5 to the exponent of -2. The last stage, guys, you can even use your calculator there. Just use your calculator. Let us see what you're going to have. But that will be 1 over 25, isn't it? Yeah, 1 over 25 there. 5 to the exponent of -2. 5 to the exponent of a -2, like that. All right, so this will give us 1 over 25. So there we've got 1 over 25, or x is equal to, this cancels. So we've got -4 to the exponent of what? -4 to the exponent of a -2, like this. And that is going to give us 1 over 16. So that will be positive 1 over 16. So as you can see, there are 2 solutions that we are finding from these typical equations. We obtain 2 solutions. So you have to be very, very careful how you simplify this. All right, so I want you to try these questions. Try also number 7 is the same thing. You can use the K method, or number 9, you can use the K method if the direct factorization is not fine, or you can even use quadratic formula. I don't know which way are you going to choose, but I want you to try this one. Then lastly, let us just check number 10. So number 10, what are they trying to say here? X to the exponent of -5 over 3. That's x to the exponent of -5 over 3 is equal to the 6th root of 9 to the exponent of 5. All right, so there we can use we just have one solution by looking properly here. We just have one solution there. All right, we just have one solution there. But how? How is that possible? All right, how is that possible? That is the question. And also, in our questions, some of these solutions, we can even bring them back to the testing. All right, we can even bring these solutions to the testing, which is another thing that I never talked about here. I never talked about that issue of testing our solutions. On this one, we had number six. But guys, we're just going to try and check them, all right? We're just going to test them, all right? But there are supposed to be two of them there, all right? But here we're just going to have one. There's no need for us to test anything here. There's just one solution. What is the reciprocal of negative 5/3? Or maybe you want to simplify this. It's up to you, guys. I'm just like trying to find a simpler way that I can use for you guys to understand this. All right, the sixth root of this gives us what? Let us check our calculator first. Let us check our calculator here. That is the sixth root here. The sixth root, that is, we need shift here. Shift. Why is it not? All right, like this. The sixth root of 9 to the exponent of a 5. That will be, let's see. Let's see, it's a decimal. All right, that one is giving us a decimal. All right, so let's avoid having it as a decimal, all right, because that one is giving us a decimal. So let us use our laws. We are stuck. We just have to use our laws. All right, remember this here represents 9 to the exponent of what? What made us to write this? We had 5/6. Remember, the denominator is written in the what? Root sign. Then we find the reciprocal of this. What is the reciprocal of -5/3? It's going to be what? -3/5, like this. -5/3. So it's going to be opposite 3/-5. So with the reciprocal here to the exponent of 3/-5 to the exponent of 3/-5, that is how we're going to do this. All right, so this one and this one cancels, guys. We get a 1. So that will be x to the exponent of a 1. X to the exponent of 1 is equal to, we simplify, remember, exponent multiplies. On the other hand, we can multiply there. All right, but on the left hand side, guys, that one, the original number and its exponent, you get a 1, but you can do that, multiply. So let's do this one. 5/6, this is 5/6, like this, times 3/-5, 3/-5, like this. We're gonna get what are we gonna get? -1/2. All right, so this is 9 to the exponent of a -1/2, like this. All right, so this is where the two solutions will come from. No problem, you will see them. How are we going to have the two solutions at the end? Because all of these questions, you are supposed to get two solutions. All right. So here we simplify. This is x, which is equivalent to this part. Now we are applying the laws of our exponents. Remember, to the exponent of a negative means 1/. So it's 1/9 to the exponent of a half. But what does to the exponent of a half means? We talked about this. To the exponent of a half, it means the square root of. So it's 1/the square root of 9 raised to the exponent of 1, which is fine. But what is the square root of 9? The square root of 9 is a plus or minus. The square root of any number is plus or minus. So you're going to have a plus or -3. So that means we've got two solutions that are being taken from there. X, which can be 1/3. Like I said, there are two solutions here. X, which can be a positive 1/3, or the X, which can be a negative 1/3 at the end. So this is how we were supposed to attempt these typical questions. We just have to play around with these questions, try to do as much questions as you can. Try to revise your basics as much as you can. It's very, very important to do that in your revisions. All right, so like I said, it is very, very important that you do revise and also to check for possible solutions if possible. All right, but here I wanted you to have two solutions on each. So guys, we shall see more questions to come from Maths Zone African Motives till we meet again.